Hi everyone, we're going to evaluate the improper integral or state that it diverges. We're going from 0 to infinity. We have ds divided by 1 plus s times square root of s. So before we get started, I want to go ahead and just integrate this. Let's just say we had an integral of dx, let's call it x, and then we had square root of x times 1 plus x, because that's usually how you see it. And so if I let u equals square root of x, then du equals 1 divided by 2 square root of x dx. So 2 square root of x du equals dx. And if I substitute back in my u, I get 2u du equals dx. Also, I can square both sides here and get u squared equals x. So basically what I can do is rewrite this as the integral of 1 divided by u, because u is square root of x, and then 1 plus u squared, because x is u squared, and then times dx, and dx is 2u du. And what happens is the u's cancel out, so you get the integral of du divided by 1 plus u squared. Now, when you integrate this, you're going to get 2 arctan, or tan inverse, of u plus c, and substituting in back here u, this is going to be 2 arctan of square root of x plus c. So now that we have that, let's get back to what we have to really do. So we really have to evaluate this from 0 to infinity. Now, it's discontinuous at 0, because you can't divide by 0. So it has the form of also at infinity. So basically, what we're going to do is rewrite this as the limit as b approaches 0 from the right. And this is going to be substitute in your b, and then we're going to go to 1. And then we have ds divided by 1 plus s square root of s. Then we're going to have plus the limit as b approaches infinity, and then this is going to be from 1 to b. All right, and then we have ds divided by 1 plus s square root of s. All right, now we can integrate this, and we're going to get as b the limit as b approaches 0 from the right. And if you integrate this, we already did that, this is going to be 2 inverse tan of square root of s, and we're going to evaluate it from b to 1, plus the limit as b approaches infinity, and we have 2 inverse tan of square root of s, and we're going to evaluate that from 1 to b. All right, so the first part, when you substitute in 1, you're going to get 2 inverse tan of 1. When you substitute in the b, we're going to go ahead and write this as the limit as b approaches 0 from the right. We have 2 inverse tan of square root of b. Plus, now we do this one. Substitute in the b, we're going to have to write the limit again. The limit as b approaches infinity, and this is going to equal 2 inverse tan of square root of b, and then we have minus, I'm going to squeeze this in, because we're doing the 1, minus 2 tan inverse of 1. So I'm going to try to write all this in. So basically, inverse tan of 1 is pi divided by 4. So that's 2 times pi divided by 4, which is just pi divided by 2. Minus, when you substitute in 0 here, we're going to get 0. Plus, when you substitute, this goes off to pi divided by 2. So when you do inverse tan of infinity, it's pi divided by 2. So we have 2 times pi divided by 2 minus, and then we have 2, and again, inverse tan of 1 is pi divided by 4. All right, so we'll just write this on top. This is pi divided by 2 minus 0. This is going to be plus pi. And this is going to be minus pi divided by 2. All right, so these cancel out. And so your answer is pi, and it means it converges. Thank you. Have a nice day. Bye-bye.